Hey guys, this is a part two of a series where I'm discussing emtb and mtb shim stacks. And the purpose of this video is to very narrowly focused. I'm just going to talk about the relationship between shims and a shim stack and Shockwiz results. Now, I'm assuming in this video that number one, you know something about shim stacks. I'm also assuming that you know what a Shockwiz is. And number three, I'm assuming that you know how to remove a shim stack. If you have this Shockwiz report, and basically in this Shockwiz report, it's showing 6 pieces of data. I'm only going to focus on the last 4 items: the low speed rebound or LSR, the high speed rebound or HSR, the high speed compression or HSC, and the low speed compression or LSC. So if you have that Shockwiz report, and if you have a shim stack in the shock that produced that Shockwiz report, this would show the shims in the shim stack over on the right. And basically, there are 5 shims to focus on in this shock. At the top part, before the piston, there are 2 16 by 1 shims. And then in the bottom part of the page below the piston, there's a 22 by 0.15 and a 20.15 and an 18.15. So those are the shims we're going to be focused on. Now, how do you determine which of those shims need to be adjusted in the stack based on the Shockwiz report? And before we go further, I want to make sure that we're all on the same place as to the name and concepts that I'm using here. So the first thing I just want to clarify, on the far left, I'm showing a green check and a red X. What this means is when I'm talking here, I'm talking about a shock that has been mounted in a bike in a traditional fashion. In other words, it's been mounted so that the front of the shock is at the front of the bike, and the back of the shock is at the back of the bike. And that's shown in a picture with the green check. By the red X, that's a shock that's been mounted upside down. And so in that particular shock, it's reverse. The back of the shock is the front of the bike, and vice versa. So I'm talking about a traditional mounting. And on most shocks, there are 2 shim stacks inside the shock stanchion. Now on the right side, at the top of the page, I'm showing the back of the shock and the back of the bike. And on the bottom, I'm showing the front of the shock or the front of the bike. There's a piston running on a shaft, and at the back of the shock, there's a shim between the piston and the back of the shock, and there's a shim stack on the other side of the piston, which is between the piston and the front of the bike. Now, this is a very busy diagram, but it's very important to understand. One of those shim stacks controls the rebound fluid movement, and the other shim stack controls the compression fluid movement. So going over to the right, at the top is the back of the shock or the back of the bike, and the bottom is the front of the shock, the front of the bike. When the shock is rebounding, the piston is moving through the stanchion from the back of the bike to the front of the bike, and the fluid is moving through that piston and through the shim stack from the front of the shock to the back of the bike. When the shock is compressing, the piston is moving from the front of the shock to the back of the bike, and the compression fluid is moving through the shim stack from the back of the shock to the front of the shock. Now, that's important because the shim stacks are identified based on which fluid movement they are controlling. And those shim stacks, or that shim stack, which is at the back of the shock or the back of the bike in my example, are called the rebound shims, and those shims which are at the front of the shock are the compression shims. Now, those shims will move dependent on how much fluid and how quickly that fluid is moving through the shim stack. So I've divided this page into 2 diagrams. One is low speed movement. So this would be when you're riding down the trail and you're hitting very small bumps very gradually. That would cause very low speed movement of the shock. It's not moving quickly, it's just responding as you move down the trail. And in that case, the fluid movement is moving and only bending the first couple of shims in the shim stack because a relatively small amount of fluid is moving at a relatively slow speed. But at the second half of this page, over to the right part of the page, when you have a big, quick shock movement, that causes a high-speed movement of fluid, and a lot of fluid moves very quickly. And as I hope you can see in my diagram, that's causing all or many of the shims to bend so that the fluid can move. Because of this, the shims are further identified based on their location in the shim stack. And this is how you get LSR, LSC, HSR, and HSC. Those shims closest to the piston control fluid movement early or in low speed situations in the shock stroke, and those which are controlling rebound, which are close to the piston, are low speed rebound or LSR shims, and those shims which are closest to the piston in low speed situations, they're called the low speed compression or LSC shims. Those shims further from the piston control fluid movement later or in high speed situations, and those that are controlling the rebound are the high speed rebound or HSR, and those controlling compression are high speed compression or HSC shims. So when you put it all together, these are how the shims are identified in a shock. Once again, top of the page is the back of the shock. The high speed rebound shims are those shims that are closest to the back of the shock, and they're shown in red. Those shims between the high-speed rebound shims and the piston are the low-speed rebound shims, and they're shown in green. On the other side of the piston, between the piston and the front of the shock, the first couple of shims are the low-speed compression or LSC shims, and those are shown in blue. Those shims which are further from the piston but closest to the front of the shock are shown in pink, and those are the high-speed compression shims. Now, with this understanding, you know that the information from the Shockwiz is indicating which shims need to be changed. So on the Shockwiz, the low speed rebound shims are shown at the top, and those are corresponding to the green low speed rebound shims on the piston. The high speed rebound shims are the high speed rebound setting in the Shockwiz information is referring to the HSR shims shown in red. The high speed compression are referring to the pink shims in the shim stack, and the low speed compression readout in the Shockwiz are referring to the blue LSC shims in the shim stack. So I hope with that information you see how the Shockwiz data relates to the location of the shims in the shim stack. I hope I've given you something to think about, and I'll see you guys at the top.